So good morning, everyone, and thank you for joining us here today. I'm Steve Percy from Sprint Networks, and I'm joined by Rod Christie from Versa Networks. Good morning, Rod. Thanks a lot for joining in.
Thank you for inviting me, and welcome to everyone.
Thank you, Rod. So over the years, Rod's been working very closely with partners like us across the region, and he brings a ton of insight and experience into how Versa can be ideally suited for the Pacific Islands. And today we are diving into a topic that hits close to home, the network struggles we deal with daily in PNG and across the Pacific. So the topic for today, which is high latency, low bandwidth links, have always been a real challenge there. But there are solutions, and we are going to give you a glimpse of how you can use these solutions to improve your business performance. So here's what we'll cover today. We'll first have a look at the real world connectivity challenges in PNG and the region. Then we'll explore how the Sprint Networks SD-WAN solution powered by Versa Networks tackles these issues using intelligent routing, security, and optimization. So just for all the folks on the call here today, this will not be a deep dive into any tech jargon. We'll be talking more real problems and real solutions here. This is for folks on the ground dealing with these challenges every day. So we'll try and keep this very practical, very relatable, and hopefully leave you with a few ideas you can start exploring right away. So by the end of this conversation, we'll open it up for Q&A as well. And if there are any questions that we can't answer on the call here today, you can always write to us at info@sprintnetworks.com. So I'll be sharing that email address at the end of the slide deck. All righty. So this slide that you're looking at right now probably resonates with many of you here on the call today, and also with the wider audience in PNG and the Pacific Islands. So the reality is, in PNG and across the Pacific, businesses, small, medium, and large, are paying thousands of kina to the local telcos for bandwidth, but they are still struggling at the end of the day. In PNG, we constantly see branch sites struggling with the same issues. Waiting forever for file downloads, voice calls dropping mid-sentence, and staff getting frustrated. And it's not just a tech inconvenience, it slows down the entire business. So over the years, we have heard this from many of our clients in places like Rabol, Kimbe, and Kavieng. And we know that this isn't a one-off problem. It's the everyday reality for many teams trying to stay connected and productive. So having said all that, what I'd like to say is that we have spent over a decade working closely across PNG and the Pacific Islands, building networks, delivering security solutions, and supporting businesses in some of the most challenging environments. We don't just understand the region. We have been on the ground, side by side with our customers, and we do see firsthand the daily connectivity issues they face. And through this conversation, what we hope to show you is that there are practical, proven solutions to many of these challenges. You do not always need to spend more money on bandwidth, because with the right technology, you can get far better results from the infrastructure you already have. So in summary, what I'd like to say is what you really need isn't just more bandwidth, it's better visibility, more control, and smarter optimization of the network you already have. And when things do go wrong, as they inevitably will, it makes a big difference having a partner and a solution that understands your environment. So someone who knows the realities of working in PNG and the islands, not someone far removed from the challenges you deal with every day. That said, we also believe in being real, whether it's SD-WAN or any solution from any vendor for that matter. It's not magic or a silver bullet. If the quality of your bandwidth is very poor or heavily congested, there are limits to what any solution can do. But what SD-WAN does bring to the table is intelligence. It helps you make smarter decisions about how that bandwidth is used, which apps get priority, and how to get the best possible experience from even the most challenging links and environments in the islands. So what you see on screen right now are 4 techniques that we implement as part of our SD-WAN deployments for customers in PNG and across the islands. So these aren't just features that we turn on with the click of a button. So just to give you an example, right, when we do a deployment for a customer, whether it's in PNG or across the islands, before anything goes live, we spend time with our customers to really understand how they operate, what applications matter most to them, what links they're using, and where their pain points are. Then what we do is we take all of that information and we recreate it in our SD-WAN lab setup here in our Sydney office. What we do is we simulate real specific telco conditions. So a 1 meg link or a 2 meg link with high latency, packet loss, just like what you'd get from telecom or Digicel or Vodafone in places like Madang or Leh. So that's how we make sure what we deploy actually works, not just in theory, but in the exact conditions you face every day. So these are practical tools that help you get more from the links you already have. Each of these play a key role, and we've applied these techniques in real-world deployments across the region, and the difference in performance, especially for business-critical traffic, for voice, for video, is often immediate. So the first feature that I'd like to talk about is having visibility of your bandwidth. So I've got a small pre-recorded video here that I'm just going to pause. I'm just going to start playing this again. So the dashboard you're looking at currently is that of our SD-WAN solution. So this is an actual customer branch in PNG. As you can see here, sorry, I'm just going to go back to that one there. So this is an actual customer branch in PNG. It's Goroka, and as you can see here, this customer has 2 MPLS circuits connecting their Goroka branch to their HQ. So one from telecom and another one from Digicel. So using our solution, we can now do a bandwidth measure on each of those MPLS circuits to check how much you're really getting from the telcos. So as you can see here, we already see some values against both telecom and Digicel under the bandwidth columns. So it says 4 meg upload and 3 meg download for telecom, and 4 meg upload and 6 meg download for Digicel. So these values are from the previous measure that was done before this video was recorded. So if you want to do a new measure, all you do is you hit the blue measure button right next to the bandwidth values, and it will recalculate it for you. So what you can do is you can use this information, you can approach your telcos, and you can let them know that you're not getting the bandwidth that you're paying for. So this feature, we believe, is going to be really beneficial for businesses across the Pacific Islands. Rod, is there something that you'd like to add here?
Yeah, absolutely. I think that the
Yes.
power of this screen and the capabilities of monitoring your links, particularly in corporate environments where you trying to understand what your links are doing at any one point in the day, is what we use PRTG and the monitoring graphs
Right.
for. And we understanding what our baseline of our traffic is going through our network allows us to identify events that happen, peaks and troughs on a daily basis, and being able to take these links as we see here and select which ones we want to monitor or look at any one time helps us gauge where our traffic is going. As engineers, we want to know, is the traffic going out through this link or is it going out through that link? Is it a combination? How much is the volume? These allow us to make decisions and be informed when we're actually talking to our telcos.
Absolutely, Rod. Thank you. So moving on to the next one, which is active load balancing. So I've got another pre-recorded video here that I'll be playing shortly. So most traditional setups in PNG and the Pacific Islands, they pick they pick one link as primary and keep the other as backup. So that means one link is always working hard while the other one is doing nothing until something breaks. So here's the thing, right? It doesn't matter what kind of links you have, whether it's 2 internet connections, 2 MPLS circuits, or a mix of LTE and VSAT. Active load balancing makes sure you're using them both efficiently. So what it does is it uses both links at the same time and decides in real time how to spread the traffic based on which link is performing better. If one link slows down or drops, the other one picks up the slack instantly. So instead of relying on one road and hoping it stays clear, you're using both routes together and getting better performance and resilience as a result. So this is one very critical feature that I'm very excited to talk about. It's traffic steering, and I've got 2 pre-recorded videos here. One video is going to talk about traffic steering kicking into action when there is packet loss, which is this video that you're looking at right now. And the one after this will show you how traffic steering kicks in when there is latency. So I'm just going to play this video right now, and then I'll talk over it. So what you're looking at right now is actually an SLA profile. So traffic steering is where SD-WAN really feels smart. It watches your links in real time and makes decisions based on how each link is performing, not just once a day, but at any interval based on how you define it. So for example, if you're on a Teams call and one link suddenly gets high jitter or packet loss, the Versa solution will automatically move the call to the cleaner path without you doing anything. So whether it's your voice or video or business critical traffic, that traffic will always go over the best quality link, while your non-business critical traffic or background updates can use the secondary link. So just before I play the video, just want to give you a little bit of context. So what exactly is an SLA profile, right? An SLA profile is a prerequisite for traffic steering to work. It's something that you define. So what the profile actually does is it checks the quality of your links and it moves traffic to the better link when there is an SLA violation. As simple as that. So if you look at the video here on the screen, you can see that, this is the SLA profile. This is our lab setup, by the way. So here we are keeping the threshold at 20%, and we are saying that if the packet loss on the link goes over 20%, then the link is going to be treated as SLA violated, and that traffic will go on to the secondary link or the better link. So now if you watch what happens here, the screen that you're looking at here on the left-hand side is a branch, and the branch has 2 connections. There's a digital MPLS connection and a Vodafone MPLS connection, and they're both capped at 10 meg. So as I mentioned previously, we have got WAN emulators that can simulate specific telco conditions, And here, if you look at the right-hand side, I've got a YouTube stream playing. So right now, when I play this video, you can see that the YouTube stream is running and the traffic is being carried by the digital connection, which is the blue line that you see on the screen right now. So the YouTube video is playing without any issues. The traffic it's hitting close to 8 meg. We have capped it at 10 meg, just to let you know. So it never goes over 10 meg. And very shortly, what you will see is the WAN emulator. And so there you go. So that's the WAN emulator. And what we're doing here right now is that we are inducing packet loss. We're inducing 25% packet loss into the digital link. So very shortly, you'll see the digital link starting to dip and all the traffic will be taken over by the Vodafone MPLS connection. So you'll see that shortly. You can see that the video is still playing on the right-hand side. So there you go. So you'll see the convergence there very shortly. You can see that the digital link has hit 3.5 meg and it's going to go down to basically a few kbps, and you can see the Vodafone link taking off right now. So there was no break in the video stream. It was seamless, right? So this is the magic of traffic steering. So what the Versa solution does is it continuously evaluates all your links. So when I say all your links, it's not just your active links, but also your backup links. And because it needs to know if the backup link at any point in time, if it starts performing better than your active link, it needs to know that it can switch traffic back. And it also has something called a recomputation timer. And what that does is that's where the policy decision is made when to switch traffic back to the working link. So right now, I've restarted the video. You can see that all the traffic is on the Vodafone MPLS connection right now, and that's completely taken over from the digital circuit over there. So this is traffic steering working its magic when there is packet loss. And the next video that I'd like to show you is what happens when we induce latency into a particular link. So here I'm showing you the SLA profile again. What we've defined is a threshold of 200 milliseconds. This is for a particular link, by the way. And if the latency on that link crosses 200 milliseconds, the solution is intelligent enough to put traffic. It'll check the other link first, and it'll make sure that the other link is performing better than the link that is going to get violated in this instance. And only then will it put traffic on the better link. So on your screen here, you can see the same setup on the right-hand side. And then on the left-hand side, instead of a YouTube session, I've got a file transfer going. And right now you can see that all the traffic is on the Vodafone connection, which is the yellow line there. And very soon you'll see the WAN emulator come up, where we'll be introducing latency of more than 200 milliseconds. So just give it a few seconds. So that's our WAN emulator. And we are putting in 250 milliseconds of latency. And that's going to be a clear SLA violation on the Vodafone connection. And that'll be enough for the Versa solution to see that as SLA violated and for it to switch traffic onto the better circuit, which is the digital circuit in this instance. So there you see, there you go. So you can see the Vodafone connection completely dying and the digital connection picking up all the traffic from the Vodafone circuit. So that's visually how traffic steering works. And anything that you'd like to add here, Rod?
I think coming back to your point about, typically in PNG
Right.
and the Pacific Islands that they're typically using one link, you can't deal with packet loss and high latency, putting your traffic on one link and
Correct.
relying on link failover. You have to have two active circuits. Sometimes there is a cost on one circuit that's higher than the other, and that prohibits you. But you still can control how much traffic is actually going through that second circuit by rate limiting it and putting it on budgets, etc. But having those two links active is what's going to deal with high latency and high packet loss.
Absolutely. Yes, yes, yes. Thank you, Rod. So the next slide, I do not have a pre-recorded video here, but what I've got for you here is a really clear example of what happens with and without quality of service or costs. So at the top here, we've got a network without costs in place. So what does that mean, right? It means it's a free for all. So whether it's your business critical applications, general internet use, background updates, everything is competing for bandwidth. There's no order, no control. That's why things like Teams calls or cloud-based ERPs often struggle because they are getting squeezed out of they're getting squeezed out by lower priority traffic. And now if you look at the bottom image, it's the same link, same traffic, but this time with cost policies applied. So we've defined how much bandwidth each category gets and made sure business critical traffic, which is the blue section that you see over there, is always prioritized. So what does that mean for the business, right? That means your business critical apps stay smooth and stable, even during peak usage. Non-critical traffic still flows, just without getting in the way of your business critical traffic. And here's the key takeaway. Cost doesn't increase your bandwidth. What it does is it just makes better use of what you already have. And in PNG and the islands, where every megabit matters, that's a huge advantage. Right, Rod?
Oh, absolutely. The core of Quaz is understanding your traffic, and you'd be surprised how many organizations don't actually realize what's going out their gateways. If you've got a good hold on that, then you can prioritize your business traffic over everything else. And certain departments, certain traffic should be given priority, particularly things like video and VoIP and voice calls. Need that extra bit of low latency. And other general traffic, where you're sharing a few files and bits and pieces or collaborating on documents, isn't as important as the voice and the video traffic in a lot of organizations. So understanding that is critical to a business.
Right, absolutely. So for all the folks on the call here today, if there are any questions that you'd like to ask us, feel free to pop them into the Q&A section and we'll take them up at the end of this conversation. So moving on to the last feature, which is TCP optimization. We all know how frustrating it can be when you're trying to open a cloud file or do a sync to, say, OneDrive or upload documents, and it just crawls, right? So that's often because TCP, the protocol used for most of your applications, it doesn't do well on links with high latency or packet loss. So for example, say there's a VSAT connection with a lot of latency or congested MPLS links from your remote branches, right? That's where TCP struggles. So what our SD-WAN solution does is it changes the way TCP behaves on these links. So what it does is instead of slowing down every time there's a bit of delay or loss, which is what TCP normally does, SD-WAN smooths out the traffic flow. It helps prevent unnecessary pauses and delays. So what happens is your file transfers or your cloud applications or your systems for that matter can run more smoothly than without TCP optimization. So just to give you an example, right? Say you have a branch in Kavieng or VVAC connecting back to your HQ or data center over a high latency MPLS connection. Just by enabling TCP optimization, you can see a noticeable difference in how your applications are performing across those links. So that's the magic of TCP optimization. And this is something that we have deployed for many of our customers across the region. And we have firsthand seen the real benefits it can do for businesses. Anything you'd love to add here, Rod, in terms of TCP optimization?
Well, optimization is essentially about, as you said, creating a better flow of traffic,
Right.
reducing the amount of traffic that you've got. This is just another tool to deal with high latency and high packet loss at the end of the day.
Right, yes. Now, thank you, Rod. So that pretty much brings me to the end of the feature set side of things. So I'll hand it over to Rod now. So that's actually just to summarize everything, right? That's a look at the challenges we face in PNG and across the Pacific, and how SD-WAN, when done right, can really make a difference. But it's not just about having the right techniques. It's about choosing the right platform to bring those techniques to life in PNG's unique environment. And that's where Versa comes in. So to walk us through why Versa SD-WAN stands out, especially for the Pacific Islands, I'd like to hand it over to Rod. So Rod, over to you.
Great. Thank you, Steve. Just a little bit of background for everyone. I've been at Versa Networks for 3 years now. I've been in lots of different roles, pre-sales and resident engineer, and I'm currently working as a technical account manager for the ANZ region, which includes the Pacific and the islands. Just a little bit of understanding about VOS and Versa Networks. We created one operating system, which we called VOS. It works in the cloud, it works on appliances, it works on our switches and our APs and in our virtualized environments as well. And it doesn't change. VOS is the same image no matter where you put it. We don't have different revisions for different parts or different models of our hardware or for our cloud or for the public cloud. So it's just one operating system, and it was designed 14 years ago to deal with SD-WAN because the co-founders of our organization came from Juniper, and Juniper didn't want to go down the SD-WAN path. So they broke away and they created Versa Networks. So essentially, for the last 14 years, we've been developing tools to help organizations with SD-WAN. We've added in firewalling and UTMs and advanced routing capabilities. And we also have a single pass architecture, and you might wonder what that actually means. A lot of our competitors, when the traffic comes in through the interface and hits the CPU, it's handed off to other virtual instances of the device to process that traffic, make decisions, and pass it back to the processor. In a single pass architecture, when the traffic comes in through the interface, it goes through to the CPU. And one core of that will take that flow of traffic and start working through and making decisions on the routing, the WAN optimization, then go through to traffic steering, applying URL filters, and finally passing that traffic back out through the SD-WAN interfaces. And if you've got multiple cores, and most of our devices have somewhere between 4 and 16 cores, you can see that we can have multiple streams of traffic going through, which enables us to have one of the higher throughputs in the industry of all our competitors from a traffic throughput perspective. Right. Next slide, Steve.
Yeah.
So looking at some of the capabilities, we've got hundreds and hundreds of capabilities, and this is just a subset that's just dealing with SD-WAN. We've got the routing side where we're making decisions about the incoming traffic and where it's going. Then we've got the SD-WAN where we're making decisions on how we're going to forward that traffic out. And the third segment of that is the security and how we're going to analyze and protect that traffic and make decisions on whether it's eligible to go out the interface. If we come back to that middle section, the SD-WAN, and you look at some of our capabilities, the things that we've got designed that actually help you with packet loss and low latency are things like cloning and striping, multiple active links, and then we've got application engineering, control, we've got audio correction, TCP optimization, we've got application control and QoS. And putting all those features together that are designed to combat some of the difficulties that we're seeing in Papua New Guinea and the islands is what makes the Versa operating system so unique in the market. That routing section that I started with is also telco grade. So just about any possibility from a routing perspective is available to you. Next slide, Steve.
Yeah.
And this is my last slide. Just it's a survey done by Gartner. It happens every year, and it rates our capabilities for large WAN deployments globally and by country against our competitors. And as you can see, we typically sit at that number one spot with the capabilities that we have. And that's about it from my side.
Yeah, thank you. Thanks a lot, Rod. So I'd like to say thanks again to everyone for joining us today. We really appreciate your time. If you have questions, feedback, or want to continue the conversation, feel free to reach out to us via email or connect with us on social using the hashtag #SprintNetworks. We'd love to hear from you.